Gianluca Parotto, and the title of my work is Experimental Investigation of Hydrothermal Aging on Single Lap Bond CFRP joints. The aim of this work consists to evaluate the effect of hydrothermal aging on single lap bonded joint made of CRP and adhesives. Usually the use of adhesive in structural application although it contains a set of advantages like the elimination of corrosion typical of mechanical fasteners and the reduction of the weight of the joints and the reduction of the local delamination of the parts with the drilling. However, the use of adhesives in structural application are limited to the complete knowledge of how it can behave in time in contact with a more or less aggressive environment. The main factor influence of the durability of the joint over time are the temperature and the humidity, but the combined effects are not always clear if the two factors act simultaneously. This activity can be divided into 4 steps. The first step is the design of the experimental plan. After the specimen manufacturing, so the aging treatment, and at the end, specimen characterization and results. For the design of the experimental plan, we have chosen 2 types of adhesive, a film adhesive IF1632K and a pass-through pass adhesive EA9309A. For the aging condition, we have chosen 3 types of conditioning. The conditioning in air, conditioning of specimen immersed in distilled water, conditioning of specimen immersed in salt water. For each combination of aging condition and adhesive, we have chosen to make 3 recommendations. The specimen was manufactured according to STM D5868 and STM D1002. In particular, on the left, I reported a sketch of the specimen used with the tolerance and with the dimension. And on the right, the specific equipment used for bonding. In the photo, I reported a specimen manufactured with this technique. For the adherence, was being used an IR 450 CC289 with 5H satin saline weight. We have chosen 2 types of adhesive, EA9309 plus adhesive and an F1632K adhesive. In the table, I reported the principal properties of these types of glue. In particular, we can state that the EA has stiffener and present a lower dust transition temperature. For the aging treatments, we have used ventilated oven and K-type thermocouple combined with a multimeter. The figure is reported the cycle for 1 day. In particular, this cycle was applied to the 3 aging conditioning for 30 days. We can state that the range temperature comes from minus 28 Celsius degrees to 85 Celsius degrees. The figure are reported the result of the lab shear test from the specimen tested. In particular, the references are taken from a previous work of the authors. From visual analysis, we can state that there are no sensible differences between the specimen with the IF1632K, in particular between the specimen aged and the reference. All the test conditions were performed for the STM D5868 with a process speed of 1.3 mm/minute. If we analyze from visual inspection the specimen tested with the EA9309NA, we can state that all the degraded specimens present higher lap shear strength. In particular, in the case of specimen aged in water, we can see an increase of about 70% in apparent shear strength. An analysis of variant ANOVA has been done for the entire population specimen tested, and the p-value chosen for reference was 0.05. From a global analysis, we can state that all the adhesive treatment has a role, in particular the shows of the adhesive. For an analysis of the results from the F1632K, it can be done a one-way analysis of ANOVA for this type of glue, and we have obtained a p-value of about 0.15. So this value is higher with respect to the reference value. So we can state that for this type of adhesive, the aging treatment are not significant. In fact, if we analyze the failure modes according to STM D5573, we can state that all the specimens produced with type of adhesive presents light fiber tear failure. In the case of VA9309, in the table I reported the results from one-way ANOVA, and we state that the p-value are equal to 0. So we can say that in this case, with this type of glue, there are significant difference from the specimen in function of the aging treatments. In particular, if we consider the failure modes from specimen not degraded, we can see that all the specimen tested present adhesive failure. But in case of specimen degraded, all the specimen degraded present mixed adhesive light fiber tear failure. In particular, we can say that from the specimen tested in air, degraded in air, to specimen degraded in distilled water and salt water, it's possible to observe a chromatic variation on green that's occurred from the that's occurred in the specimen degraded in water, in particular in distilled water. For a measure knowledge of the behavior of this type of glue, it can be done a DSC analysis. In particular, in the image I reported DSC results for specimens not degraded. So we can see that it's present an endothermic peak near 60 Celsius degrees. Probably this endothermic peak is due to some unreactive components. In fact, this type of glue has a polymerization at room temperature, so probably does not allow the total cure of the adhesive, this type of polymerization. To be noted that there are no significant difference between the edge of the adhesive in the specimen and the bulk behavior of the specimen. In the case of specimen degraded air, we can say that there are no endothermic peak. Probably this is due to an effect of post-cure of this type of treatment. In particular, also in this case, we can state that there are no significant difference between the edge and the bulk of the adhesive. But in the case of the specimen degraded in distilled water, we can see that there are some difference between the edge and the bulk of the adhesive. In particular, in the edge is also present the endothermic peak. Probably in this case the water penetrates into the adhesive and not allow to a total cure. But in the bulk of the adhesive, the water doesn't arrive, so the temperature reached during the aging probably affect a post-cure, as a post-cure effect. In the case of specimen degraded in salt water, we have an intermediate behavior between the specimen tested in air and specimen tested in distilled water. This is probably due to a more difficult salt water to penetrate into this type of adhesive. Probably the increase of operational stress is due to the specific geometry of the single lap joint. In fact, this type of specimen presents a singularity of stress near the edge of the joint. In fact, where if this part is more degraded, this part presents lower resistance but a greater plasticization ductility. So the greater ductility of the adhesive localizes into the streams can allow to attenuate the presence of this singularity. It can generate a more uniform load. This is showing in an increase of apparent resistance of this type of joint. In conclusion, in this work, the effort to hydrothermal aging on single lap bonded joint made with two types of glue has been investigated, coming to the following conclusions. In the case of the F1632A, aging did not affect the shear strength. And in the case of VA9309A, aging affected significantly the shear strength of the bonded joint. Particularly, in the case of aging in air, this glue has a post-cure effect, and aging water also increases the shear strength in direct proportion to the degradation of the edge of the adhesive. This occurs because adhesive presents lower resistance localized in the edge but greater plasticity, where the styrus present a stress singularity. This is the end of one work. Thank you for attention.